Okay, guys, today we're going to be moving forward with functions, and today we're going to be evaluating functions. So the title of our notes today, Evaluating Functions Notes. Before we get started here, I want you to try out these warm-up problems up at the top. I want you to determine if the following representations are functions, and then why or why not. All right, hopefully you were able to give those a shot on your own. And the first one, in that map, if you look at the map, you'll notice that this 1 is being dragged to two places. This 1 is being dragged to the -2 and to the +2. This makes it not a function because the inputs are repeating. The x values are repeating themselves. And the second one in the graph, you use the vertical line test. You'll see that when you drew your vertical line, it touched that graph twice. If you need to write out the points to see why, this is -2, 2, and this is -2, -2. Those x values were used twice, which means it is not a function. And in the last example, the map, you'll notice that each one of those inputs is only used once. In other words, each one of the inputs has only one arrow coming from it. We do not care that this 6 over here is used twice or that this 1 is used twice. We don't care about the outputs. We only care about the inputs to determine if it's a function. Before we move on further, I want you to take a second and remember the different names that we have for x values and for y values. Go ahead and try to fill in those blanks. If you'll remember, x values, a synonym for that is an input. Another synonym is the domain. And one more that you can tack on that you'll often hear it be referred to is the independent variable. It is the one that is driving the change. On the other hand, y values, another word for those, output, or the range, or the last one is the dependent variable, the one that is a result of the change. Today, our job is going to be evaluating functions. We're going to be plugging in values into functions. Now, you might think of them as similar to an equation because we're plugging in for x. We still have variables and numbers. But functions are different than equations because functions have a name. There's a lot of differences, but one difference is they have a name, and they are named with a letter. So if you move on to this next box, you'll notice that we have this big old thing that looks like f with parentheses and x. That letter out front is the name of the function. Not a very interesting name, but this is the function f. The thing that's in the parentheses is the input. It is what you are plugging into the function. What is being plugged in to the function. So in this case, it's x. X is being plugged into the function. But in the future, we're going to plug in a number in place of x. Then I want y'all to draw a little equal sign off to the side. Whatever we plug into the function, we're going to plug in a number. We'll get something that comes out of the function, and that is the output. When we look at this, we don't just read it as f times x. We read this as f of x. If there was a different number in the parentheses, like a 3, we would say f of 3. If it was a g instead of an f, we would say g of x. So it's the name of the function of whatever's in parentheses. So kind of like I was saying, going along with that, f of x does not mean f times x. F of 5 means what do you get when you plug 5 into the function f. Each answer that you get represents a point or an ordered pair. Whatever you're plugging in is the x value. Whatever you get out is the y value. So for example, if we plug in 5 into function f and we get out 15, that means the ordered pair that results would be 5, 15. Let's move on down to that first example and evaluate our first function. This is telling us that f of x equals 4x minus 2. If we want to find f of 3, they're telling us now to not plug in x into our function, plug in 3 in place of x. That's all that is telling us to do. It's just some math notation. So we'll take that 3 and we'll put it where we see that x right above. Let's try it beneath here. So f of 3 would be 4 times 3 minus 2. Remember, when two numbers are linked and they're just smushed together, that's a multiplication. And then follow your order of operations to finish up. So we have 4 times 3 is 12 minus 2. 12 minus 2 gives us 10. So 10 is our output, meaning that on this function, if you plugged in 3, your end result, your output would be 10. Now, maybe you're thinking, well, that represents a line. 4x minus 2 is a line. If you're that advanced in your thinking, then that's awesome. You would know that the point 3, 10 was on that line. Let's try out the same thing for example number 2. Now we're finding f of 6. That means we're taking this 6 and we're plugging it in where we see an x. Now, if there are multiple x's involved here, you would plug that 6 in multiple times, but there's just one 6, so we're going to plug it in there. So we have f of 6 is equal to 6 squared plus 5. Now remember that 6 squared is not 6 times 2. 6 squared means 6 multiplied by itself twice. And those exponents come before addition. So we have 36 plus 5. 36 plus 5 gives us 41. So that would be our answer. If we were asked to write it as an ordered pair, you'd go back up to what your input is. Your input was 6. Your output is 41. Remember, all that represents is a point that would be on this function. So if you graphed this, we won't get to that till second semester, but if you graphed this, it would form a parabola. So that's telling us if we graph this parabola, then the point 641 would be on it. On our next page, we're going to continue practicing plugging in and evaluating functions. On this one, we have a function g. It's going to work the same way. G of 2 is asking us to plug 2 in place of x. Now, if you look at that function above, you'll see that there are 2 places to plug in x. You plug them in to both spots. So let's give it a shot. We have 3. We see an x. We plug 2 in its spot. Plus 2 times, we see another x, so we plug 2 into that spot, plus 5. Now use your order of operations. Remember that exponents come before multiplication, so we have 3 times 4 plus 2 times 2 plus 5. 3 times 4 gives us 12, plus 4 plus 5. So we get 12 plus 4 is 16. 16 plus 5 is 21. Now, if you were going to write it as an ordered pair, as your second part of your answer, your input was 2, your output was 21. Similar to the one we just did, this is going to form a parabola. We'll get to that second semester, but it's telling us that if we plugged in 2, an x value of 2, then the output would be 21. The point 221 is on that function. Y'all go ahead and give this next one a shot. Pause the screen, plug in for x, and we'll see what you get for your answer. All right, let's see if you got that correct answer. You plug in negative 10 in place of x. So we have negative 10 cubed times negative 3, subtract 2. Negative 10 to the third power is negative 10 multiplied by itself 3 times, so we get negative 1,000 times negative 3, subtract 2. So you get 3,000 minus 2, which is 2,998. If you were going to write it as an ordered pair, you have negative 10, 2,998. If we look down at our last set of examples down here for evaluating functions, you'll see that we don't just have a plain old number. Now we are plugging in an entire expression. The same deal works out here. You're going to take that entire x plus 2, and you're going to plug it in place of x. So instead of x being in the function, now we're plugging in x plus 2. Please make sure that you put up parentheses when you have an expression that you're plugging in, because there's going to be distribution that has to be done. So we have 3 times the quantity of all of x plus 2 plus 1. Go ahead and distribute that 3. Make sure that it goes to the x and the 2, and then simplify. So your 6 and your 1 get added together, and we would have 3x plus 7 would be our final answer. You don't have to write it as an ordered pair when you have an expression that you have to plug in. So we would just say that that answer would be 3x plus 7. I want y'all to pause the screen and try the example 6. All right, let's see how we did here. You should have taken that 5x minus 3, plugged it in for where you see an x into the function above, and then make sure that you put up these parentheses so that you remember to distribute that -2. So the -2 is multiplying by the 5x and the -3. See, that's where we get the -10x plus 6. Then the 4. Add your like terms, and you get -10x plus 10. Let's try it with a real-world scenario here. We're going to try to write a function rule and then evaluate it. Also, we're going to identify the input and the output for the function. So we have Tyler. He's buying pizzas. Each pizza costs $12. The input is the number of pizzas that he's going to buy. If he buys a certain number of pizzas, what is that going to affect? That's going to affect his output, which is his cost. The function that we'd write here would say that the function f of x is equal to $12 times the number of pizzas that he buys. So if we saw this, what is that telling us? Well, in the x's spot, we see 4. Remember that the x represents the number of pizzas. So if he buys 4 pizzas, what's that going to cost him? Well, it's going to affect his output, which is $48. So if he buys 4 pizzas, it would cost $48. By the way, we can say that this output up here is f of x. So the cost, the output, is going to equal $12 times the input. Let's try it again with the problem beneath here. Tim buys a souvenir cup at a football game for $4, and every refill he must pay 50 cents. Our input, or the thing that's going to be driving the change in his cost, is the number of refills that he gets. We're going to call that x. It's going to affect his output. Well, what's his output? Again, it's the cost. So see if you can write a function connecting the input x with the output cost, keeping in mind that he initially paid $4 for that. Hopefully you were able to come up with f of x equals $4 plus 0.5 times x. So his initial cost was $4, but then he has to pay 50 cents for each refill. That will affect his output, his f of x. So down beneath there, if we wanted to decide what f of 6 equals 7 means in context of this problem, look first at what's in the x spot. We see a 6. So think to yourself, what does that x represent? The number of refills. So if he gets 6 refills, what does this 7 mean? Well, it's on the other side of the equal sign. It's our f of x value. It's the cost. So it will cost him $7. The last thing we're going to look at is evaluating functions from a graph. So if you'll flip it over to your last page of notes, we're going to look at this top graph together. I want you to notice a couple things. First of all, we have 2 functions on this graph. We have z and we have t. Those are just the names of the functions. Remember that when we look over to this right side, the name of the function is out in front, and the thing that we're plugging in for x is inside the parentheses. So this is asking us, if it says find z of 2, this is asking us if x equals 2, then y equals what? So we look at our z function, and we specifically go to when x is 2. So look on your x-axis, remember that's the horizontal one. When x is 2, and we toggle up onto the graph, when x is 2, we have a point on that graph. What specifically is the y value? You should get 7. So z of 2 equals 7 in that case. Now we're going to find t of 0. So this is asking us if x equals 0 on specifically the t function, then y equals what? So we'll go to x is 0. Now we're going down to t. If x is 0, then the y value there would be about negative 1.5. So we would say t of 0 equals negative 1.5. Next one, we're going back to z. Z of negative 4. Remember that inside there is your x value. So go to negative 4, toggle up.
I want to thank you all for being here at our.
We have a point there. Toggle back over to the y-axis to see what y value that is. You should get positive 5. Y'all try out t of negative 5. I'll give you a second to do that. When you go to t of negative 5, you're going down to the t function. So go to when x is negative 5, go over, and you should get somewhere around negative 6 is the y value that results. So if they give you the piece inside the parentheses, they're giving you the x value. Notice how these remaining ones are a little different. Now they're asking us if z of x equals 8, find x. So now this is asking us if y equals 8, what does x equal? So we're going to z. I'm going to clear out this screen real quick, just a second. I guess not. I'll use a different color. So now we're looking at the y value. So go to y value of 8. And we're going all the way over to the z function at that spot. We see a point there. Toggle down to the x-axis to find your answer. And you should get 5. Let's do it with the other function as well. Remember, this is the y value. So we go to y is negative 4. And you should be looking at t, and you look both directions. There's a point in either direction. That means that there's 2 answers here. So if we go to the right, it would be positive 2. If we went to the left, it would be about negative 3. So you get 2 and negative 3 as your 2 answers there. And our last one, let me try to find a totally different color. If we have z of x equals 9, that is your y value. So go up to when y is 9, go over to your graph, and then go down on the x-axis. You should get 8. I want y'all to try out the problems beneath there using that parabola. Keep in mind, when the value inside the function is given, they're giving you an x value and asking you to find a y. If they give you the number after the equal sign, they're giving you a y and asking you to find the x that goes along with it on the graph. I'll pause the screen, you pause the screen too, and try those out. In this first one, they're giving us the x value of 6. So we go to the x value of 6 over here. Remember, your x-axis is the horizontal one, and go down till you reach the function. You'll find the point there. We want to know the y value at that point. The y value you should have gotten is negative 6. Next one. They're telling us that x is negative 4. So go to the x value of negative 4. Go down to your function. You'll see it where it hits. And we want to see what that y value is. You should have gotten negative 2. So those are both of the examples where we're given an x value. Now let's try out when we're given a y value. In this one, our y value is 2. So we go up to the y-axis. Remember, that's the vertical axis. Go to when y is 2. What is your x value at that point? Your x value that you should have gotten is 0. And last but not least, they're giving us a y value of negative 4. So we go down to negative 4, and we can either turn left or we can turn right, which means that there are 2 answers for this. So we go over, see a point there, state what that x value is. You should have gotten 5. And go to the left. You should have also gotten an x value of negative 5. Come to office hours if you have questions on any of those pieces. I'd love to help you out.